Great, now we're recording. So, the reason why we covered relational algebra is because it sharpens your ability to express SQL queries. SQL is a more powerful language than relational algebra. We will start to see today how to take queries stated in relational algebra and how to rephrase them in the SQL language. So SQL, the language, is a larger language than relational algebra. But being able to understand relational algebra and the way to phrase queries is an important part to being able to express SQL queries in an intelligible way. Not only intelligible, but in your ability to write relational algebra queries will help you phrase SQL queries correctly. That's why we spent so much time on it. We're on the downslope of the hill as far as how this works. So, given these tables, first I'll just ask something simple, and then I will go into a bit of a spiel on how to change things. But let's say if I wanted to select people, sailors from table S1, make that more of a 1, who are over the age of 48. How would I phrase this in SQL? And I'll give you 2 minutes. I think that if you don't know, like you've never seen SQL, don't worry, just sit back and wait 2 minutes. Otherwise, for people who might have had some experience in SQL in the past, I want to give them a chance to say how they would approach this. So from this table, S1, how would you, in SQL, return the entries where people in this table have an age greater than 48? I'll wait 1 minute. Okay, so I see 2 answers. Let me type this. Select age from S1 where age greater than 48. Okay. So this was the first answer that was posed. This is yeah, not quite right for a couple of reasons. One, here you would at least need to type s1.age. Can't just write age. Other than that, who is this? Jamie is correct that this would just return the age columns. But I'll remind you that the sigma here, this filters out tuples from a relation. And the tuple is a vector, where the vector includes all of the dimensions. If you just wanted the age, then you would have to add a project here. If I asked the question, project age, this would be the way that I would end up with this type of result. But there's no projection here, so I want the entire thing. And one way to do that would be, as Jamie says, to have a star here. So there's a few points here. This select and this in relational algebra, the sigma stands for select. But this relational algebra select is not the same as the select here in, let me make this bigger, in SQL. So do not confuse the two. There is not a one-to-one correspondence. It is not the case that this select is this select. They are different. This whole thing is a select in SQL. So in SQL, a select has three components: the select statement, the from statement, and the where statement. We will be talking about each of these parts from the SQL select momentarily, but for now, this entire thing is a select statement in SQL. So each part of it is, even though I'm writing them on different lines, these are not different entities of the select statement. The whole thing is a single SQL select statement. So what this does is the star means everything. And this is true in not just SQL, but in other languages. If you're, oh boy, if you're familiar with DOS, or this is also true in regular expressions. A star means sort of a blank space for as many characters as you want, or just everything. The from here is pointing, so let's see, this select star means return all columns, or return, yeah, all columns. The from, this is from which table? So this is pointing to the S1 table. And the where is what this select actually corresponds to. So the select in relational algebra corresponds to the where. The where is the filter. In relational algebra, let me back up. The where in a SQL select statement corresponds to the sigma in relational algebra. So the sigma in relational algebra is the filter to filter out tuples, and the where in SQL is the workhorse for eliminating rows from a table. Okay, I have some more things to say about this, but let me keep these here, I guess. Before I do that, are there any questions about what I've said so far, or about what this select statement does? Good question, Eric. You should say s1.h. Yeah, not just age. Yeah. Okay. Does it matter if we say 48 or 48.0? Here it doesn't matter. Okay. So let me continue. Now I'm going to go into some things that you should be aware of for the SQL language, as well as just by itself, which will have an actual tangible effect on the results that are returned. Therefore, it will be required for not only this class, but also when you're writing yourself after this class SQL statements or reading them. Other things are going to be for this class requirements that I have as far as how you phrase SQL statements. You can keep some of these after class, but there will be things that you could write in the SQL language that would be correct. So there's the way that you could write it, and then there's the way that I would like you to write it. And these two things will have identical outputs. But for this class, I'm demanding that you write it in the way that I would like. And I'll justify those along the way. First, for the tangible part, the thing that makes this that will result in different outputs if you don't have it. Okay, first of all, before I do that, this select statement that I have written here, what would this return? Yeah. So this would return, actually, can I, ooh, nice. It would actually return this. So in the same way that relational algebra queries a relation and returns a relation, SQL queries a table and will return a table. And just like a relation has a schema, the table also has a schema. So please remember that. It would not just return this 31 Lubert 855 because this is missing the schema. So it returns the schema as well as an entry. Same way as relational algebra returns a relation. Great. Now, yeah, the thing that I want you to know is distinct. This word, distinct. So when you add a distinct in front of the star, what this does is, and maybe this particular example doesn't work to elucidate this point, because you're returning everything. There's no projection. If there was a projection, it would make an actual difference. But, well, here, let's go ahead and do it. If I were to write another project here, project name, and let's say in this table, I had another entry like this. Without this distinct, what this would return would be, move this, would be this. So it returns two entries where we have a repeat. And this is because in the same way that the select in relational algebra is something that's applied to every single entry in a set, the select in SQL is also applied to every single row in a table. So this row matches this condition, s age greater than 48, as does this fourth row, where the age is also greater than 48. So because the second and the fourth rows both satisfy the where condition, then the result is the name repeated. Which sometimes you might want to happen, but most of the time you don't want it to happen. And in the same way that we talked about in sets, if we're now shifting gears to just the mathematical notion of sets, the set with 3 elements 1, 2, 3 is equal to the set of elements 1, 1, 2, 2, 2, 3, 3. In the mathematical notion of sets, these are identical. Repeats don't matter with sets. So in order to, this on the right, when you do have repeats, is what happens when you do not have the distinct word. But by adding distinct here, it enforces that you get this result with no repeats. So you're actually returned just a set where every element of that set is distinct from its neighbors or other elements of that set. Neighbors isn't right. There's no order in sets. Is that clear? Okay, so this is a very tangible, real thing that does have an effect for the outputs. Without the distinct, we get this result. With the distinct, we get this result. Okay? So, for this class, every query that we have will use this distinct word. If you leave out the distinct, you must give a reason why. Why is it important for this query for repeats to matter. There's some cases when this does matter. If you're counting or you're doing some type of aggregation operations, then repeats can be an important thing to take into consideration. But for the vast majority of cases, repeats are not important and in fact can kind of screw up the output that you want. So this is a tangible, real thing that you should be aware of, and that unless the query demands it, unless you have a very good reason to want to count repeats, then you should always use the word distinct in a select SQL statement. Okay, I think I've emphasized it enough. Now, that is the only thing that will have a tangible effect on the output. Now there's the parts that I will want from this class. These aren't necessary insofar as the outputs from these SQL statements will be identical. So it's a correct answer if you look at the inputs and the outputs. But the phrasing is something that I want to insist on for this class. So that is to say, you'll lose points if you give answers that don't follow the things that I'm saying now. And I'll justify them as best as I can, why I'm doing this. First of all, the from. I want you to rename it. Every single table that you reference in the from statement, I want you to give it a new name. So here, I'll do it this way. Where, hold on. So the above is the, I'll put here, done right. I'll put it in quotes because the output is the same. Here, in the from line, if I write as something, this is how you rename something. So this is the row in relational algebra. I'm renaming a table. And here the where would be rephrased like this. Okay? So for every table that you write in the from statement, I want you to rename it as something else. The reason why I insist on this, and again, the output will be the same. These will both return this. Output is the same as the above. The reason why I insist on this is because when you start dealing with a lot of different tables, in particular, when you're referencing the same table many times, then things can get very confusing. And so giving a unique name to every time you instantiate a table, in particular the same table many times, renaming it can help you not lose track of what you're trying to do. That's why I insist on it. Okay? Something only gives you the S name of looper, not the other data of looper. Oh, no. you're right. This returns this. If I wrote s1 or here s dot name, then that would return here. Let's do this. So the project actually happens in this select here. So this is the projection. Thank you. I'll keep it like this. How do you decide which looper to pick? It doesn't matter in this case. Yeah. Sorry. Let me this here. Here it doesn't matter which looper you select. They're identical. It would be like in here if I have a set 1, 2, 3, and then here I have the same set 1, 1. Why isn't this writing? 1, 1, 2, 3. These are identical sets. This one here is redundant. So this one on the left, is that the first one or the second one? Doesn't matter. They're the same.
Professor?
Yes.
I just have a question, but it's better if I just speak it than type it.
Great.
How could I understand why it doesn't matter in that scenario? But what if you had done select distinct star? Wouldn't it matter which lubber you pick out because they would have two different ratings?
Yes, that's correct, which is why I added the projection here. Because then you do get the same set. So,
oh, okay.
Yeah. Here, let me make this a little bit cleaner. Sorry, and thank you guys for bringing up some of these things. All right. So, here. As Brian very correctly pointed out, if you have a select distinct star from this, then this would return 2 entries. Because, again, this star returns the entire tuple, or the entire row, and here each row is distinct because the ratings are different. Here, when you're returning just the S name, then you only get the one looper back, and it doesn't matter which one, because for the set reason that I was just speaking about. Okay, so yeah, thank you guys for that. Other questions about this? No. Okay. Okay. Well, this is actually good because now I can do something else here. This star is something. So the first thing. So there's 3 things that I'm concentrating on here. The first is this word distinct. This has a tangible effect on the output. You will get a different output on the same table if you have the word distinct and if you don't. So unless you have a specific reason to want repeats, you should always add the word distinct. This avoids mistakes. Not only for this class, but in the real world. I mean, people will not add the word distinct and then they double count and that's not what they meant to do, and they were just confused about the SQL language. So I'm heavily emphasizing it. Use distinct unless you have a very good reason not to. The other thing is this. Okay, so this is the tangible thing that's different. For this class, the first thing I want you to do is to rename tables. This doesn't have an effect on the output, but when you're writing, in particular, complicated SQL queries where you're referencing the same table many times, renaming it makes your life a lot easier and will avoid mistakes. The second thing that I will ask for this class that does not have a tangible difference in the output is that I don't want you to use star. I want you to write explicitly the columns that you want. So here, again, I'll rename the table. And if I want everything returned, then I will write s.sid, s.sname, s.rating, and s.age. Okay, so here, the result of this, I'm asking for every entry of this table. The output on here, the right-hand side, these two are equivalent as far as they both return the same table on the right. Now, the reason why I'm insisting on this for this class is because tables can change. When you're working with a SQL database, oftentimes you're working with other people, or maybe it's just you yourself, and I don't know, you're working over some extended period of time where you can forget things. Now, tables can change. So if this is a query that I've written for some reason, then because I'm requesting the SID, the SName, the rating, and the age, then that should be important for things that follow this SQL statement. There's a reason why I wanted these 4 entries. And later, if this table changes, then this second statement will break. So if a new column is added, everything's still okay. I wanted these 4 attributes and their values, and so everything that follows, no problem. But if a column is deleted, then now this is going to break. And maybe somebody else changing that column, deleting a column, was a problem. And now you've caught the problem because you have something that breaks early on. You can find exactly where it broke because maybe something that I wanted to use the sname on, for example here, I explicitly asked for it because I was planning on using it later. And so now I've found the problem as soon as I can. You're not digging through lots and lots of code to try to narrow down where the problem happened. You find it right away. So, again, just to reiterate, I will you should use distinct, always, unless you have a specific reason not to. You should rename tables. Doesn't affect the output, but it makes your life easier. And it will also help you make conceptual mistakes. This, don't use star. If you want every single entry, ask for it explicitly, because you have a reason to want the entire table as it exists. This avoids more pesky problems. Okay? Do you need a column? Do you need a comma? Yeah. I'll add commas here, thank you. By the way, this when you're renaming a table, you actually do not need the as. You can just say from S1S. But again, this doesn't have a tangible effect on the output, but it is easier to remember what you're doing if you write the as. That I don't insist on. In fact, sometimes I might leave out as accidentally. But that's not something that I insist on. The other things I do. Questions? Great. Okay, so I've already jumped ahead a little bit. My first question was just using the select here. My second question was using the project in addition to the select. So all right. So what we're going to be doing for the rest of this, let's see. Yeah, for this class, the next class is delving into what is actually happening here with the SQL stuff. But I wanted to emphasize again why we studied relational algebra and the fact that relational algebra actually, it's a very easy thing to go from relational algebra into SQL. So here, the relational algebra select, this is applied to every single tuple of the relation, and the select is happening here in the where statement. The project is what happens in the select portion of a SQL select statement. Okay. So I'll end on this note and we'll pick it up from next class. So all right. This corresponds to the project in relational algebra. This is predicate applied on each tuple. Okay, so the same way here, that a select is applied to every single element of a relation. This where is applied to every single row of a table. And the from, I guess I'll give this away a little bit for the next class. This is a Cartesian product. So the from is where there's a lot of behind the scenes things that aren't difficult to understand, but I want to heavily emphasize what's actually happening. And the from is where a lot of the engineering behind SQL actually happens, a lot of the under the hood stuff. The where is the most difficult part when you're actually trying to phrase a query correctly happens in the where. So the select is the simple part. The select is just a projection. That's just which attributes you care about printing in the output. So the from is where a lot of the mechanics happen, and the where is conceptually where you spend most of your time trying to figure out which rows to return. So that's it, and thank you guys. I will pick this up on Thursday.